Hey everyone, good evening. So, right now I will be working on some portions of our swap methods using linked list. So, I was thinking I'll do the most common one, and the thing that you probably might see often. So, the most common one that you generally learn is swap using values. Then in the next series I will cover swap using values using linked list, swap using position. So let's do these linked list first. So let's do the linked list nodes first, and then we will look at the array ones. All right, so with that being said, let's all right, so let's write the code. So let me just open Sublime, and I think I already created a file, although it's empty. Yeah, it's just called llswap.py. And actually, let me just move this file. So let me just open our warp cd desktop. Okay, move our llswap.py, sorry, move our llswap.py to yt code. Okay, now let's go to our yt code, and there you go. Yeah, I have the folder called linked list, which only has llswap.py. So in fact, I'll just move our llswap.py to our linked list. Yeah, sorry, my bad. Swap.py. Okay, and let me just move to our yt code, sorry, move to our linked list, and there you go. So we have the basic linked list that we learned today morning. So the previous video that I uploaded. So today I will be doing ll swap. In fact, I'll change it to ll move llswap.py, right, to ll swap. Okay, swap using values. Okay, swap using values, and which also is is also part of linked list nodes. So I'll just put nodes in the end, nodes.py. Okay, finally, since we have it, so ll swap dot using that value. No, I'm just going to open it in Sublime. All right, so now that I have it, so let's create a class for the node. I'm going to just create a basic class, so as opposed to the the big one. So let's do here, and of course we need a self. So in here we of course need the value, or data. So I'll just call it data, and I'll just say self dot data equals to data, followed by and self dot head by default. Okay, or self dot next obviously is equals to none, right, and that completes our entire node. So I'm gonna write the rest of the code in our linked list. So class linked list, right, we have to define the init function. So there you go, def init, and it takes self, and let's say I'll append the values later. So I'm not even gonna give any value right now. So I'll just say self dot head equals to none, and let's write a append function here. So def append, and let's say we are appending a new data, right? It takes self and new data. So let's create a new node. So new node equals to node of new data, right, and we just have to check if head is null, right? So if head is null, right, so let's write if self dot head. Okay, we can just write if not self dot head, which basically means it's null. Okay, if not self dot head, then we can just set self dot head equals to new node, sorry, new node, right? If that's not the case, then what we want is, let's do last equals to self dot head and my idea is that I just want to move until the last item where the next is not null. So I'll say while last dot next. Basically it means that just move until it gets null. While last dot next, last equals to, sorry, last dot next. Great. So with the while loop being done, now finally let's add the values. So we'll just say last dot next equals to new node. Perfect. So that's that takes care of the appending. And also let's print the list just to be sure, so that we can see what are the values in here. So I'll just call some function called print list or something, which takes a self, and here I'll just put temp equals to self dot head, right? Obviously I'm just assigning the value, and then I'll write, oh, I forgot this is Sublime, so yeah, right. Right. So, and also let me decrease the variable so that you guys can see everything at the same time, maybe a little bit bigger, right? Perfect. So I'm just gonna do while temp, while until it becomes null. I'll just print temp dot data, and in the end, what should the end be? Should we just put something like I guess just a space should be enough, or maybe a comma? I'll just put a space for now. Okay, and then I will write temp equals to temp dot next, and if there are no values, I'll just print an empty list. So if I call this and if I see nothing, I'll just put empty list, or just to be sure. Okay, after this I'll just write if not temp, maybe if not temp, print empty linked list, right? And then I just want to move all of this, so I just want to put an else here and move all of this. Great. So with that done, I'll also need a new line after the entire print, so I'm just gonna add a print statement here. Alright, so that takes care of our print list. Great. So with these two done, now finally let's add our swap. This takes x comma y, and it also takes our self, right? Okay, so the first instance, I just want to check if x and y are same, right? And then there's no point in swapping, so I'll just say if x double equals to y, I'll just return. Right. So with that done, now so understand that in order to define any node, generally we would need 4 nodes. Sorry, in order to swap 2 nodes, we need 4 nodes, because we have to keep track of these 2 nodes, the A node and the B node, or the X node and the Y node, as well as the previous nodes for them, because we want to ensure the lengths. So what we are going to do is I'm going to just create one called previous X equals to, I'm going to put it to none, right? None. And I'm going to take current X and I'm going to give it to self dot head, right? And the idea is that I want to parse until I get the actual X, right? So I'll just say while current X, and current X dot data is not equals to X. So while this is while this is not null, and the data is not equals to X, just keep moving. So I'll just say previous X equals to current X, it becomes the current one, and current X equals to current X dot next. So that's the idea for current X. Okay. In the same way, let's do it for y as well. So I'll say previous y equals to none, my bad, sorry, none, and then I'll write current y equals to self dot head, and it's the same procedure here too. So we'll just do while current y and current y dot data, if it is not equals to y, right? Again we'll just do previous y equals to current y, because we are just iterating, and the previous one always has to be in front of the current one. So current y and current y equals to current y dot next. Perfect. After this, we will do some basic checks, like make sure that neither current x or current y are null, right? So we'll just write if not current x or not current y, just return, I guess, where there's no point, right? So after the if is done, then we want to check if previous x, let's say if this is the head, like maybe I have like let me just draw an example here. So maybe I have a list like 5, or a linked list called 5, 10, 15, 34 and 56, and here a is 5 and b is, let's say, 34. So obviously a would be head, right? And if it is a is head, then obviously previous x would be null, because, or null or none, because this function, sorry, this iteration never executes, because we already get the value, because current x dot data is not equal to x is going to be false. So that's why we're going to check with our first one. So we'll say if previous x, sorry, if not previous x, obviously, which means if it is null, then we'll just say self dot head equals to current y, right? Because then we are going to swap the current x with current y. That's the idea. Else, now if it is not null, then we'll say previous x dot next equals to current y. In the same way, we're going to do the same for we're going to do the same for previous y too. So again, if not previous y, self dot head equals to current x, obviously. Else, previous y dot next equals to current x. Great. So we already set the values. Now we just have to take care of the, okay, so we already took care of the previous values. We just have to take care of the next values, and it's a basic temp swap, like 3-digit swap. So I'll just do temp equals to current x dot next, right? Now since I stored the current x dot next in temp, I can just do current x dot next equals to current y dot next, because I want the next value of current y in current x, and current y dot next equals to temp, and that should take care of our swap. So let's go check it out, and as as usual, obviously all of this is going to be in the git repo, and it will be in the video description too. So let's run this. So let me just create a linked list, an empty linked list. So I'll just call it linked list, and since I did not give any way of adding the value here, sorry, at the init, if I have to add any values, I have to use append. So, and I did not bother with a insertion at the beginning, insertion at the end, because it doesn't make any difference here, because our main concern is swap. So let me add a couple of values. So in fact, let me just add these values, okay, 5, 10, 15, 34 and 56. So list dot append, right? Now let me just copy it. Does command D work? No, it doesn't work here. Okay, so that's 5, 10, and then we have 15, right? And then 34. I can see the values here, so that's why I'm able to type them. Then 56, right? So I appended all of them. Let's do list dot in fact first let's print the list. That's one, and then let's swap two values. So let's swap, I'd say, how about we swap 5 with 34. Okay, and let's print the list again. Alright, and let me just run the code. So we get python 3 ll swap using value nodes.py, and let's run it. So there you go. So this is the initial one, which is 5, 10, 15, 34 and 56, and once I swap the values I get 34, 10, 15, 5 and 56. So as you can see, 5 and 34 values are swapped. So perfect. So it's a very straightforward algorithm, honestly. As long as you understand the basics of pointers and linked lists, so it's a very common one. So just make sure to take care of all use cases. So I can just say I couldn't say use case, I can say call it scenario, I guess. Scenario 1, so that's scenario 1, and this would be scenario 2, right, if any of them are null. Alright, and if you want, you can assign, you can claim this as scenario 3 and scenario 4, if previous x is null or previous y is null. Alright, and then I think that's about it. Alright guys, so that covers today's video, and in the next video I'm gonna focus more on changing it using the position and everything. And for now, in fact, if I want to do the swap using position, all we have to do is all we have to do is just create an array and just swap the arrays, swap the values using the array. In fact, if you guys want, let's do swap using position, but the point, so sometimes you might get a question. I think it was a lead code question where they give you an n and they want you to swap the nth linked list as well as the k minus n, where is k is the length of the list, k minus n. So they want you to swap, if imagine they give you 2, so they want you to swap the second thing with the fourth one. So we just have to create an array to do that, but I will cover that in the next video. So I'm really glad that you guys are watching, and I'll see you guys in the next video. Thank you.